Hi everyone and welcome to my Go course. Today we're going to talk about data types in Golang. So Golang provides several categories of data types, which are basic data types, composite data types, reference data types, and interface data types. So in this video I'm going to show you a quick overview of the data types in Go, and in the next videos we'll talk about all of them more in details. So let's start with the basic data types. Basic data types cover actually numeric data types such as integers, unsigned integers, floating point numbers, booleans, and strings. So for example, here I have listed the data types for the numeric data types, for example, integers, which in Go has several precisions for integer data type, such as integer 8, 16, 32, 44, and this number basically means the precision of the data type, which is the amount of bytes used, allocated to store the value of this data type. So for example, for integer data types, 8 means it uses 8 bits or 1 byte to store the value of it. And for example, here I wrote several declarations of the variables. As you remember, this underscore sign means that we simply ignore the name of the variable so that the Go compiler doesn't complain about not using it. And for example, for the integer data type, I can assign any positive or negative value, but it should be an integer, not a floating point numbers. For example, like this. I can also use for example, hexadecimal literal to assign an integer value, and so on and so on. There is a special case of integer data types, which is a run. A run is basically an alias for the int32 data type, and it's used to store the Unicode characters. So why do we use this? It's just basically um, it's just basically the case to use a special syntax for the um, runes. Instead of typing int32, we explicitly say this is a rune, and with runes we can use a character literal, a rune literal. For example, for the character A, I can use this single quotes, and this will be the value of this rune. Go also has unsigned integer type, which, the same as integer types, have different precisions from 8 to 42 bits, but comparing to integer data types, unsigned integers use all of the bits for storing the actual value of the integer, because this signed integer uses 1 bit for storing the sign of the number, whether it's positive or negative, whereas the uint or unsigned integer type uses all of the bits for storing the value. It means that you cannot assign a negative value to it, only positive value. And same as with int, you can use, for example, a binary literal to assign a value, or any other literal, for example, hexadecimal literal, and so on. There is a special case also for unsigned integers, which is a byte data type. Byte data type is simply an alias for uint8. So 8 bits is 1 byte, and you can assign it any byte value. So let's move on, and the next type are floating point numbers, and here we have two precisions, 32 bits and 64 bits. Let's move on. The next basic data types is Boolean. So Boolean data type has only two values. It can be either true or false. We'll talk more about this in details in the next videos. But for now, let's move on. The next data type is string. So string in Golang, it's a basic data types. A variable of the data type string basically stores the value of the string, not a reference. So this is an example of a string literal. So we'll talk more about this in details in the next videos, as I said, also. And let's move on. And the next category of data types in Go are composite data types. And we'll start first with arrays. Arrays in Go, as in other programming languages, are simply the sequences of elements of the same data type. But what's special in Go about arrays is that the length or the size of the array, it's basically the part of the data type. So the size of the array belongs to the data type. It means that, for example, in this case, this int 4 array and int 5, if I, for example, declare an other integer array with the size 5, these are two different data types. This is not the same data type for Go, because this way Go guarantees that the length or the size of the array is known during the compilation, and in this way Go guarantees that all of the elements of the array will be placed one after another in the memory, and the size of the array cannot be changed in the runtime. This is an important restriction. It doesn't make this data type very practical, but this restriction is always guaranteed. The next composite data type is struct. Struct is basically a sequence of named elements of one of the same or maybe of different data types. And struct basically, you can in this way you can use using the struct literal, you can define an empty struct without anything, or you can use the type keyword followed by the name, and using the struct literal and define your custom struct, for example, like this. And as I said, struct is just a set of named values which are called field. So each field has a name, field name, and a data type. So in this case, I am declaring a person struct with the fields name and age. Name is a string data type, and age has the integer data type. And in this way, I can declare a variable of this struct data type, and I can assign it. I can even assign it a value by using the literal of struct, and I can write the values for the fields, for example, like this, or I can use the names of the fields explicitly, because in some cases it can be confusing if you have several fields with the same data type. So this syntax is also valid. Okay, let's move on. And the next category of data types is reference data types. And the first reference data type in Go is slices. Slices, you can see them basically as dynamic arrays. What is the difference between normal array in Go and slice is that for the normal array in Go, the length of it, the size of the array should be known during the compilation. So it belongs to its data type. And slices are dynamic, and slices are references. So every slice can contain underneath can contain an actual array, but it provides you a set of operation for manipulating this array. We'll talk more about this in details later. So here I just listed some examples, for example, an integer slice, a string slice, a person slice, and same as with array, I can initialize it using the literal and like this, or I can here the same. I'm using the slice literal, and here I create a person with the name hello. Okay. So the next reference data type is map. Map in Go is a reference data type, and it's used to store key value pairs. So this is the syntax. How can you define a map variable? So you basically use the map keyword, and in the brackets you write the data type of the key. So this map, for example, will use string as the key data type, and Boolean will be the value data type. So for map, there is also a syntax for a map literal. I can actually write it, for example, like this, string and Boolean. And I can give it some values. For example, the key hello will have the value false, and the key world will have the value of true. And the same you can do with other map type. There are several restrictions for the key data type. Basically, for now in this video, I'll tell you that you can use any basic data type as the key of the map, and absolutely any data type as the value of the map. About the restrictions, we'll talk about the restrictions of map data type in the later video dedicated to maps. But for now, let's move on to pointers. So the data type for pointers basically is used for storing the memory address of a variable, of an actual data type. For example, in this case, I have a pointer to an integer value which stores the value of which stores the address in memory of the integer variable, for example. And there is a syntax. For example, if I would like to initialize this variable, I cannot just write, for example, the value integer, because it should be an address. So for this, I should declare a variable. For example, let's call it I, and I'll just write I and give it a value 45. And there is a special syntax by using the AND sign and the name of the variable to obtain the address of this variable in the memory. So this variable will contain the address of this variable. And for the struct or for the composite data types, there is also special syntax. I can just, without declaring and initializing a variable, I can use the literal straight away. And the Go will allocate some memory for this struct and will assign this variable an address of this memory area. The next reference data type is a function data type. So functions in Go can be used as actually as variables, as arguments to the function, as return values. And here I have an example of defining the functions as a variable of function data type. Here is another variable of the function data type, which has an integer argument and string returning type. More about this we'll talk in the later videos. And the last category are the interface data types. Basically, the interface data types, this is a huge topic. We'll cover it in a dedicated video. But for now, you should know that if you have, for example, an interface data type variable, you can only assign the values to this variable which satisfy this particular interface. So this is it with the data types overview for now. hit the like button if you like the video, and subscribe to the channel if you want to see more. And thank you for watching, and see you later.